Today we are going to be looking at writing equations to represent functions. This is standard 3C that we will be talking about in this unit. Please make sure to have your notes out so you are taking notes on the video and get credit. Again, we want to emphasize the fact that this unit is dealing with making algebraic connections, connecting graphs, tables, equations, and story problems together to piece together the best representation of a problem or situation. The first kind of situation that we'll have to write equations from is in a table. If we look at the table below, we can see that as x moves up steadily by 1 each time, y is moving up by 10. We're adding 10 each time. Take a minute and think about how we might write that in an equation where we have y equals and something happening to x. Go ahead and pause the video, get an answer down, and click play when you're ready to see the solution. Here our equation was y equals 10x, because as you look at the x value, if you multiply it by 10, you get our y value. 1 times 10 is 10, 2 times 10 is 20, 3 times 10 is 30, so on and so forth. If you compare these two tables, you can see that we have x and y in the top table, and in the bottom table it's x and 10x. So really what this tells us is that y and 10x are the same thing, therefore that is where we get our equation stating that y equals 10x. Let's try one more of these in a table form. In our second example, it's easy to see that in our table we're adding 2 each time. So we know that something happening to x we're going to be multiplying by 2. So go ahead and take a look, see if you can write your equation, and then when you're ready, click play again and look at the next slide to see if your solution is correct. If you got y equals 2x plus 3, you have done this correctly. As you can see, we're adding 2. That's where our 2 comes in before the x. But if we look back at our example where x is 0, 2 times 0 is 0, but we should be at 3. So we have to do 2 times x plus 3. If you look at 1, 2 times 1 is 2, plus 3 makes 5. And it will work for each value that's remaining in our table. Again, we look and compare the top two tables and see that where we have y in the top table, we have 2x plus 3 in the bottom table, so our equation is y equals 2x plus 3. Next, we want to look at what happens when we have a situation in graph form. Here, we have labeled some points for you. This may not always be done. You may have to identify where the points are yourself. But the first thing you're going to want to do is take these points and put them into a table. So we put the point 0, 5, 1, 6, and 2, 7 into our table. And then you're looking at finding the pattern. Well, each time we go up 1 for x, we're going up 1 for y as well. So I'm going to give you guys a minute, pause the video, see if you can come up with what that equation might be. Remember to keep that 0 case in mind. What happens when it's 0? What do we have to do? And when you're ready to see the solution, hit play again. Here you can see that we got our equation y equals x plus 5. 0 plus 5 is 5, 1 plus 5 is 6, 2 plus 5 is 7. So we can see that our equation y equals x plus 5, we see it there and in our table. Let's try one more where we have an equation in graph form. Again, you're going to want to take a minute and plot your points into your table and figure out what is happening to y as x increases. Here you can see that we are adding 3 each time. Now is the time for you to pause the video, see if you can come up with what the equation might be, and play the video when you're ready to check your solution. Here we get our equation y equals 3x minus 1. As you can see, each time we go from one point to the next, it's going up 3. However, if we multiply 0 by 3, we get 0, and we need to be at negative 1, so we have to subtract 1. Similarly, if 1 times 3 is 3, well, that's too many, so we have to subtract 1. And 2 times 3 is 6, so we have to subtract 1 to get down to our given y value of 5. Again, you can compare the two tables and see that y is in the same location as 3x minus 1 in the lower table, and that gives us our equation y equals 3x minus 1. Now we're going to look at two situations in story problems, so in written form. In the first situation, Joey began the day at his job with $6 in his wallet. Joey worked a 4-hour shift that day, making $9 per hour. The very first thing you're going to want to do is create a table of values for the situation. Go ahead and create your table as you pause the video, and then hit play when you're ready to compare your table with the one that we've created. Here we've created our table. We know that at 0 hours he has $6, and each hour after that it goes up 9. So he makes $15, or he has $15 after 1 hour, he has $24 after 2 hours, he has $33 after 3 hours, and he has $42 after 4 hours. Now that we see our progression, we know that this is going to be y equals 9x, and we need to look and say, okay, if we multiply 0 by 9, we get 0. How do we get to 6? We have to add. So when we compare that with our solution, we get 9x plus 6. 9 times 0 plus 6 gives us 6, and it will work for every set of coordinates in our table from then on out. You can again see that we get y equals 9x plus 6. Now, in this case, we didn't label our original table as x and y. We labeled it as hours and money. So this, usually in our table, x is the top thing. So in this case, x represents the hours in our situation, and the bottom thing is generally y. Therefore, in our situation, y is the money. So this is saying Joey's money in his wallet is equal to $9 per hour that he works, plus the $6 that he originally had. Let's look at one more situation in written form. In this situation, Sarah is taking a road trip in her car, and her car uses 4 gallons of gas per hour that she drives. At the beginning of her trip, she has 30 gallons of gas in her car. Again, the very first step in this is we want to create a table to represent our situation. Go ahead and pause the video, create your table, make sure to label your variables, not x and y, but what do they actually represent, and then hit play when you're ready to compare it with the actual solution. Here our two variables are hours and gallons left. So at 0 hours, she has 30 gallons left. She hasn't driven. After 1 hour, she only has 26 gallons left. 2 hours, 22 gallons. 3 hours, 18 gallons. And this table could go on until she has no gas and would need to refuel again. What we see is that she's losing 4 gallons each time. So we know that this is going to be a negative 4x somewhere. But we need to factor in what happens at 0, because negative 4 times 0 is still 0, but we want it to be 30. If you look at our situation, we can see that we have 30 minus 4x. So 30 minus 4 times 0 gives us 30. 30 minus 4 times 1 is 30 minus 4, so 26. 30 minus 4 times 2 is 8, so 22, so forth and so on. Again, we can see that our equation is y equals 30 minus 4x in our situation. And here we have hours, which is on top, being our x. So x is the number of hours that she's driven, and y is the gallons remaining in her tank. So it says the gallons remaining in her tank is equal to 30 minus 4 gallons per each hour that she drives. Make sure you have all this in your notes, write down any questions that you have, and bring them to class tomorrow. Have a great day.